Assalamu alaikum. My name is Muhammad Ruslan, and in this video we will talk very briefly about the clean architecture. I'm gonna be very shortly and briefly summarizing what's in this book, Clean Architecture, by Robert C. Martin, or aka Uncle Bob. So as a start, what is clean architecture? It's a way of structuring how your code looks and how your directories are structured to separate each layer from another. So it's mainly primarily concerned with the separation of concern. Like the first solid principle is single responsibility. So what does that mean? It means that if a file can process and operate its function without needing to be directly coupled to another file, it should be separated in a separate file. Let's talk about that in details. For example, Uncle Bob separates or divides the application into three main layers: the feature or the presentation layer, the domain layer, and the data layer. The presentation layer is whatever the user is going to interact with, like screens, buttons, widgets, and so on, and also includes the state management methodology that you will be using to keep track of the state of the data that the user is interacting with. For example, if the user is signing in, so he sees the sign in screen. If the user clicks on the login or sign in button, the first state is loading, so state management returns that the authentication process is loading, so you show a loading indicator. If it's done, then the response will be fail or success. So if it's success, it will show something indicating that it's success, or it should directly redirect to the home screen, or if it fails, it should display an error message explaining what went wrong. So this is the presentation layer. It should be we should not implement any logic or any backend fetching or updating code in the UI layer. It's only about the UI. Why? First, if later we wanted to update the UI without updating or getting near the logic or backend layer, it's already isolated in a separate file, so we can easily find what's to work on, and we can update it without the need to go through the backend and logic to make sure that's not affected by our code updates. This is the main reason. There are other reasons that I just don't want to take the video too long. The domain layer is concerned with this is the core layer. This is the business logic layer. Here you implement the logic that's the middle layer between the UI and the backend. For example, there is another picture that explains it in more details. So this is a presentation layer. We already talked about that. It contains the state management, the page or the screen, and the widgets or the components that builds up the screen. The domain layer is the middle layer between the presentation and the data layer. What it does is it implements some use cases. What is a use case? It's a very simple abstract call for a logic or a function that's implemented in the data layer. For example, if we continue talking about the login or sign-in scenario, a use case here is user sign-in or fetching user profile use case. So just a very simple call. It doesn't have a direct implementation. The implementation is written here in the backend and the data layer. This case is just what the UI calls to call the data layer, so it's sometime in between. We also put here the models or the classes that's gonna be displayed in the UI, and we put the interfaces that's to be implemented in the data layer. I'm gonna talk more about what an interface is. Okay. The interfaces in the domain layer is put into a repository directory, and there is also a repository directory in the data layer which implements these interfaces. If you're not familiar with the concept of interfaces, it's okay, you don't have to do it. It's It's required more in large scale projects. Our project in Roots is not that big, but it's a very important topic to go through if you're gonna continue working on Flutter or any programming language that works with object-oriented programming concepts. Okay, so this is the domain layer. It's a layer in between the data and the presentation. It's concerned with the business logic, and it has the interfaces that's going to be implemented in the data layer. So the data layer is just an implementation of the interfaces that were mentioned in the domain layer, and it's responsible for connecting or communicating with the backend or the data sources. You can have the data sources like a remote data source, like using an API to fetch some data from the database, or you have a local database. So this is what the data layer does. For example, if we have a use case like a user is going to update some data in his profile, so he goes to the profile screen, inputs some data, some new data, and then we try to update this data in the backend. What happens here is the user sees the presentation layer, the profile screen, and the widgets that build the UI of the profile screen, like the text fields for the name, email, and so on. So he enters the new data, then he clicks on the update. What the update button does is it calls a use case in the domain layer that's called, for example, update profile use case. What this use case might do is to validate if the data is entered correctly. Like, the user cannot enter an empty field and ask us to update it. It cannot be empty. So we first validate the input of the user, and then we call a function from the data layer to send the new data to the backend and get us a response, whether it's updated or not. So the data layer takes the data that's already validated in the domain layer and push it to the backend and send us a response whether it's updated or not. Then the domain layer updates the UI layer that it's a success process, and we should in the presentation layer display that it has been updated successfully. So here in this way, each layer is separated from the other layer, and we can update them easily, and they are not directly coupled with each other. Hence we implemented the clean architecture. So I have created a somehow sophisticated document about everything you need to know briefly about clean architecture. So this is a brief introduction about clean architecture. This is how we do it in code, like how we structure every layer. Like every layer, like for example, we have features. A login is a feature. What a feature is something that has a UI and logic and a backend. Like for example, the authentication or the login feature has a sign-in screen, a logic that validates if the user input is valid, and then the backend layer that should perform the login API and so on. So we each feature has 3 layers: presentation, domain, and data layer, and each layer has its own directories. For example, let's start from the bottom. The presentation layer had the widgets, the single components that builds up to build the screen that's called the sign-in screen. So we have widgets, pages. Why it's pages, not page? Because you can have an authentication feature. An authentication feature can have the login, the sign up, the forgot password, and the reset password. These all can be called authentication feature. If you want to separate them even more, you can create a single feature for the sign-in, another one for the sign up, and so on. But if they are all gonna use the same logic for validation and the same UI components, then if you separate each one in a single feature, you are gonna repeat the same code for the widgets and pages and validators in each separate file or feature. And this is the opposite of a clean architecture. you should eliminate redundancy. So you can gather them together in one feature. So what is a feature? A feature is a feature in the app, like login, sign up, settings screen, home screen, and so on, that has a UI, a logic, and a backend. It doesn't have to have a logic and a backend. It can have also just a UI, like an onboarding screen, just a screen that shows up when you open the app for the first time, just introducing what this app does. So I'm gonna go through some code examples in a minute. And the block, which is the state management, we put it in the presentation layer because it's responsible for showing the user the state of the action that's been being processed. For example, if the user is clicking on sign in, it's gonna be loaded, gonna display a loading widget until the sign in is done, and he should be directed to the home screen so the sign in is correctly done. Or we should display an error message explaining what went wrong if something went wrong. Okay, so this is the presentation layer. The domain layer is the core or the business logic layer, which has the entities. These are the classes that's gonna be displayed in the UI. For example, in the login screen we have a class called user, so we should implement the user in the entities directly. The repositories contains the interfaces, which is a very abstract class. So if we have a class called login, and there are some implementation of the login process, like the user can log in using email and password, the user can log in with sign in with Google, sign in with Facebook, and so on. So the interface, just the login class, is gonna be put here in the repositories in the domain layer, and the implementation of the login process for each type of login is going to be implemented in the data layer. We put here the Firebase code for logging in with email and password and so on. And the use case is just a call from the presentation to the backend. So if I want to call the login, I use the use case that calls the login feature that has an interface in the repository, and that's implemented in the repositories in the data layer. So it's getting complicated, but I'm gonna try to explain it furthermore. Finally, we have the data layer. The data layer have three directives: the data sources, which could be the APIs or the APIs from the remote database or the local database. The models, which are the classes that I'm getting from the backend before converting them to something that I can display in the UI. And the repositories, as we said, it's the implementation of the interfaces of the classes that we mentioned in the domain layer. Getting so complicated, so let's explain it a bit. Okay, I've mentioned some explanation for each layer, but let's go through a code example for the use case. I know that the use case is one of the most for me it was one of the most confusing parts of the clean architecture. So for example, if we took the user login process, the user login has a user repository. Repository is just an interface of the user, and we at first, before we call the login feature, we should validate if the user input is valid. This is a very simple validation, like validating if the email is empty and the password is empty. Or we can put more validation, like implementing our own validator to validate that the email contains something at something, and the password is at least 6 characters and contains uppercase letters and lowercase letters and so on. Okay, so after the validation is done, if it's okay, it's gonna pass. If it has something wrong, it should left is just the failure case of the either, or just like a fancy way of saying it's throwing an exception that something went wrong. If not, then we're gonna call the function that's implemented in the repository of the user that login and we pass the email and password. This login feature is put at an interface in the domain layer and in the domain layer in the repository directory, and implemented in details in the data layer. Like the Firebase code is in the data layer, and the interface, just the abstract class, is in the domain layer. Okay, this is another example. Fetching user data, user details use case. For example, if the user is going through his profile to update something, we should fetch the profile at first. So also we have here a user repository, and at first we execute that to validate if the user ID is not empty. If it's empty, we're gonna throw an exception, else we're gonna await user repository to get us the data from the backend side and pass to it the user ID. Okay, I hope that's clear for now, and I'm gonna go through the other layers and details later. Okay. This is just an explanation of what I have just said. These are differences that I have studied this tutorial before I explain it to you. They for a very best the most effective way to study clean architecture is through the documentation from the Uncle Bob Clean Architecture book, or there is a full course called Clean Architecture. This is a video on YouTube, so it's free, and it's explaining clean architecture using the board way, which is the most effective way in my opinion. And then there are some code examples. So it's a very straightforward tutorial. It's a bit long, but you're gonna get a very good grasp of what a clean architecture is. There is a concise summary video. I advise that you see that after you understand it, or before and after, if you want to take a very quick look, then explain it, take the in details explanation, then a recap. This is a good source. And finally, there is a Medium article, also explains it in details. Okay, let's go through a real code example. This is the first one, which is a very basic one. This is a project that I have started working on it 2 days ago, so it's pretty fresh. Okay, what we should do is, when starting a new project, we put nothing in main. That's the demo code. But if we were to start a new project, let's start over. Let's delete all of this. Okay, so there is only the main function that's calling run app my app. Then we should create a stateless widget called my app. Stateless is better than stateful in this case for better performance and less memory use. That should return a material app. That means that we are using the material components of the famous material library. The first thing I like to do is to remove the debug flag, so debug false. Then the home screen, we here call the home screen. I don't think I have implemented the home screen, but let's say we are going to go to the sign-in screen first. Okay, so that's it. The main should not contain any logic or UI code. Later you may need to add the Firebase initialization code here, or Firebase characteristics and so on. That's mandatory to be put in the main, but don't let the main be crowded with like routing or other logic or UI code. This warning says that it should be const, but actually shouldn't. Later you will put some code that's not constant, so this will make some errors. If you want to leave it for now, it's okay. Very good. So after that, we create our features. So we add a directory for features, and as we said, a feature is anything that can be considered in our language as a humans as a feature, like login, setting, screen, and so on. So how we create a feature? We start by creating a directory with the feature name like settings screen. And as we said, each feature has 3 main directories, which are, try to memorize them with me, the presentation and the data and finally the domain. Very good. Each one has its own subdirectories. Like for the presentation we have widgets, we have pages, and finally we have the manager or the controller or the state management layer. In the domain layer we have the entities. I spelled it wrong, sorry. Entities is the classes or the classes that are gonna be used in the UI layer. We have the repositories or the repository, sorry, I put that into that. Okay, this is just the interface of the classes that's gonna be further implemented in the data layer. And finally we have the what? Entity repository. Sorry, I forgot. Yeah, the control. Okay, data layer, we have the repository. Why we have 2 repositories? Here we put the class interface and here we put the class implementation. The data source, and there is another one I always forget, the endpoint, which you could put the API endpoints here, and the models, yeah, of course. You don't have to have them all. Like as we said, a feature is anything that can be called a feature. So an onboarding screen can be called a feature. What is an onboarding screen? I don't have an example for now, but let's search Google for an onboarding screen. UI app onboarding screen. This is just the screen that appears whenever you open a new application. Just explains what this application does. Dribble is a very good website that I go to whenever I search for inspiration for UI design and so on. So this is a screen that appears before the sign in if you open the app for the very first time. So it's just some pictures and text that explaining what we do, then you go to the sign in. So it has absolutely almost no logic at all. So this is a feature, but it doesn't have all the directories as other features. So if we were to create an onboarding feature, I'm sorry about the noise in the background, but my mic has a very high gain and it captures all the noise from around. So the onboarding feature has the presentation layer, and that's it. The presentation has some code, some widgets, if so, and some pages, and that's it. You can add a qubit if you want, or a block, just to keep track of which page are you in if you have multiple onboarding pages, or you can just define an index and go through them by next or skip button. Very good. Okay, so this is all about the features. I have here the authentication layer. By the way, you can add your own directories if you don't know where to put them exactly. For example, that's not the best practice. For example, if here the auth validator should be in the domain layer, but as I said, this is a new project, and usually I grab some code, some reusable code from my old projects and put it in new projects and then refactor it. And this is a very good indicator that you are progressing and learning new stuff, to look back to your code and see that how bad it was, because you know better now. So the auth input validator, this is just a class that validates if the input is correct. This is the regular expression that validates that the email is formatted like something at something.something, and this is a function that to validate the password, like it's not empty, contains more than 6 characters, and contains a small letter and a lowercase letter, an uppercase letter, a numeric digit, and a special character. So where should we put this? This should be put in the domain layer, not in another directory called auth utility functions. But if, as I said, you don't have to follow the clean architecture line by line. It's not Quran, but this is what most people do. Okay. So this is not implemented yet, but this is a very simple explanation of what each feature has. I also add a core directory. This is other than the features, and in the core directory, some people call it shared, some people call it common, and as the name says, it contains the components that's gonna be used across multiple features. So it's not related to a single feature, it's gonna be used across the app. So instead of putting them in one feature, then repeating them in another feature and so on, we collect them and add them to a single directory called core. So what does this core have? Let's start from the bottom. It have some widgets. These widgets are gonna be used like buttons. Almost every screen has some buttons. Media swiper, if you have some pictures and you wanna go through them swiping left and right. Rating button, search bar, text fields, video player, and so on. So these are this is a set of features, a set of widgets that I use in multiple features. So I collect them in a directory called widgets, in another directory called core, and I can reuse them in any other feature. I usually implement my own buttons to make it as customizable as possible. Like I can pass a function on press do what. I can pass a child or a text, and I can only pass one of these. Font size, background color, foreground color, these are all nullable, so I have some default values if I didn't pass another value. Yeah, so this is very good for customization from one app to another. I have my own version of the switch button, the text button, the copy to clipboard button, and so on. Okay, media swipe, rating bar, these are not repeatedly used. I have my own version of the text field. This is the most customizable one. These are all variables that I pass to the class. I'm not sure if this is the best practice or not, but I feel like I can customize it as much as I want. These are all almost all nullable, except of enabled or not, and this is also have a value, default value. Yeah, it has a true default value, and the controller, because the text field must have a text editing controller. Okay, and this is the text field. Anyway, this widgets directory has the widgets that we're gonna be using across the whole app in multiple features. Okay, we have some utility functions. These are functions that's gonna be used also across multiple functions features, like date utility functions. For example, converting a datetime instance to a string, or the opposite, extracting just the time from a datetime instance. Like I don't want the year, month, and day. I just want the time, like 12:30 and so on. Parsing a string to datetime, parsing time to datetime, and so on. Like one of the most useful ones of these is like the timestamp to string, or the timestamp to datetime, because we get the date from Firebase as a timestamp. There is image utility functions. Like I pass the image URL, and this class is responsible for checking if it starts with HTTP, small or capital, then it's a network image, so it returns a cached network image. A cached network image is just a network image, but it's stored in the cache, so whenever I revisit the page, I don't have to reload it and fetch another request. If it ends with an SVG, it returns an SVG image. If it's not any of these, it's an asset image, so return an asset image. And if the image URL is null or empty, it returns asset image.noImage, which is like an error image, which is this one. Okay. So yeah, these are just features or functions that I'm gonna be using across multiple features. Very good. This is the screen utility functions. That is a very old code and not very organized, so don't mind it. There is the theme, which is a very important class. For example, it contains the app colors, which is the color palette that we're gonna be using across the app. So whenever I want to access a simple color, I just type app colors dot. This should display all the colors. So not my colors, maybe because I'm calling it outside of. For example, let's display text here. This text has text style, text style, color, app colors dot. Should at first import it, then we should see all the colors in our color palette, not the material or Cupertino colors. Very good. And for the same manner, if we are gonna, you should implement the text styles to look the same in all screens. You can have multiple text sizes and text weight from bold to normal and so on, but they should all look the same, and you should have like not more than 10 or something styles. For example, if I were to display hello, instead of every time I want to display hello, I pass the text style like font size 16, and then the font weight .w 600 or something, then the font family Cairo, and so on and so on. Instead of repeating typing this all over the app, and later if you wanted to update the style, you will have to go through all the files of the code and update the style line by line in every UI component. You can implement a set of text styles and just reuse them across the app. So I have a bunch of these. I just say app text styles. Just gonna import that. This is not a constant, this is what I was saying. So dot, why isn't it important then? Anyway, theme dot of context dot text theme dot, yeah, I have a bunch of these: body large, body medium, body small, display large, and so on. Where are these implemented? These are implemented in the core because they are going to be used multiple times across multiple features. So we have app text styles. First we have the app text sizes. As I said, you don't have to have multiple sizes, just like from 5 to 10 or something. So I have small, which is 14, medium 16, large 20, and so on. Then I have app text styles. I'm gonna be using one font family across all the apps, so I define it once as a static variable, which is Cairo. Then the text color is app color is just text primary color. This is defined in the app colors that we have just visited a minute ago. Very good. So I define a basic class, and all the classes should be implemented, should be extended or copied. Like the base style is font family, which is Cairo, and color is text color, which is text primary color. So all text styles will have these properties, and then I'm gonna have a variety of them. Like I can define text style called title small, which copies from the base class, this one dot copy width. I'm just gonna change the text size to medium and the font weight to W700, which is a bold font weight. I can have a title medium, body small, body large, and so on. Then I should go and implement these in the app text style. So app text theme, sorry. So I have an app text theme, which is theme text theme. Here I use a decorator, if you are familiar with the decorator pattern. So I implement a text style decorator. Then I have a bold decorator, a normal decorator, an italic, and an underline decorator. What a decorator is? It's a class that wraps another class and adds some feature to it. So for example, the normal or the bold decorator has a style, so it applies a simple extra property to the text style, which is font weight dot bold. A decorator is, we usually explain it like you can have a plain coffee, this is a base class, or you can have a coffee with milk, this is a decorator. Have a coffee with sugar, and how many sugars. You can have a coffee with chocolate or whatever, and so on. So this is the decorator. This is another topic called design patterns. Maybe we can discuss it later. This is about the theme. Sorry, I'm taking too long. I'm almost finished. Shared classes. Here we put classes that's gonna be used across the whole app. We have a shared library for that, but in this project, this is a very simple small project, so it doesn't have a shared library. So you can put the shared classes here. Constant, you can add the constant text here, like constant error messages, app name, and so on. The text that's not gonna change across all the app. You can also add the app constants here. You should have only one of these, like const or app const. Like app images. When you add an image to the assets, and instead of every time you use it, you copy the path. Sorry. Then you go here, for example, and say image.asset and pass the URL. You shouldn't bother about where the URL is. This is an SVG image, not an asset. I'm sorry. Anyway, instead of doing that, you can just say app images. This is a class contains all your images, so you can call them by name, like Google logo, for example, and that's it. Okay, so all your images should go here, also your icons and so on. Very good. App keys, sorry, you shouldn't see that. App keys are API keys, and app measures. As we said, you should have consistent text style across the app. You should have consistent padding, consistent size boxes, consistent border radius, and so on. So I define small padding, medium padding, large padding, and so on, and I use the same values across the app. So whenever I create a new padding, I don't say 8 or 10, because I'm gonna lose track what did I use in that widget and what should I put in this widget. I just implement some static values for them. I just use 3 or 4 values. This should vary from one UI UX designer to another. Okay, so this was a very long explanation of a very simple project, but anyway, I'm gonna just go through a very quick another example. This is a larger project I have been working on with Amr for like 3 months now. So in a larger project, Amr likes to add a numeric value in the front of the name just to keep that one at the top. Then this is the second and third one. So we have at first the features, and then the business logic layer. These are some state management qubits or blocks that's gonna be used across multiple features, so we define them out of any specific feature. And this is also a general data layer which contains some backend code that's going to be used across multiple features. So you don't put it in one single feature then repeat putting it in other features. So you put it in a generic or shared data layer. Then there is the core, which we just explained, which contains the theme, the widgets, and so on. The generated and the LN. These are the localization files, auto-generated. It gets auto-generated and you cannot move them from here, unfortunately. So they have to be directly under the lib folder. These are for the localization, for like if your app supports multiple languages like Arabic and English, you should have a text for every word. Like sign in is called in Arabic تسجيل الدخول. In English it's called sign in. So you just call the key, which is sign in, and according to which language are the user using right now, it should display sign in if it's English or تسجيل الدخول if it's Arabic. So you don't have to go through each and every file and put if condition in front of each text to check if it's English or Arabic. Very good. In the features we have why did I get here? Yeah, I just wanted to explain that in larger projects you will have more directories, and this is an example for the onboarding screen just as a presentation, and the widget doesn't have to have all the other layers like data and presentation. Some layers like notification only has the data and presentation. Some other sophisticated layers like the authentication has the data, domain, and presentation, and so on. So you don't have to put all the clean architecture directories line by line in every feature. It's there just to make your code more flexible to change and more agile, more sustainable, testable, and for scalability, and code reusability. If you want to copy your code to another project, it's not directly coupled to many files, so you can just take one file without doing thousands of updates just to be able to pick one single widget and put it in another project. Like for example, as I was saying, whenever I start a new project, I take the core directory and I just paste it in the new project. I just have to update some very minimal lines of code like the imports and so on. So just under like 3 or 2 minutes and I'm good to go with all these reusable components. I don't have to implement them from the beginning. So clean architecture, I know it sounds sophisticated at the beginning, very complex, but actually this is exactly what I thought at the beginning, but when I got used to it, I can't go back to what I was doing before knowing what clean architecture is. It's here to help you to make your code more simple, more readable, more agile, to change, to be updated anytime. You can update the UI without going back to the backend. You can implement the backend and you don't have the UI yet, or you can implement the UI, then the backend can work. Backend team can work on their own folder later and integrate both in the domain layer, so you can have multiple teams who work on 3 different layers and they don't have to mess in the files of each other. So this way we achieve the separation of concerns. Each class has a single responsibility and the code is reusable. You can move it across multiple apps very easily. I hope this was useful. If you have any questions, please don't hesitate to reach out. I will leave this document on Notion for your reference, and if it's not clear yet, maybe we can have a longer meeting or a recording explaining a code example, for example. Thank you so much. جزاكم الله خيرا. Goodbye. Assalamu alaikum.